Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams.
We are now at question 4 of this CXC CSEC June 2013 General Paper 2 exam video solutions. And in this question 4a, we are given a diagram of an isosceles triangle CDE, and we are told that this point G on the base CD is the midpoint. G is the midpoint of CD. And so if this is an isosceles triangle, it means that this length is equal to this length. That's an isosceles triangle. This base angle is equal to this base angle. And if G is the midpoint of CD, then this line GE represents the perpendicular height of the isosceles triangle, such that this GE would be the perpendicular bisector of the base, meaning that GE passes through the midpoint of CD, which is G, and also is perpendicular to CD. So this line GE is perpendicular to CD. But we can measure all that information to confirm that it's an isosceles triangle. And in fact, this question wants us to measure and state some dimensions of this triangle. Now the first part wants us to measure in centimeters the length of DE, that's this side, and the second part wants us to measure angle ECD, that's this angle right here. So to measure this length, we use our ruler to measure that length, and this animated ruler is brought in here, and this is how it will be placed. Our ruler would have to be placed such that we have 0 at one end of the line, and we measure up to the point D, and based on this measurement, this length of this line ED would be 5 centimeters, and so we can show that ED or DE is 5 centimeters, and so we can show that. And because it's an isosceles triangle, this length also would be 5 centimeters, and we could proceed by measuring that. But we were told it's an isosceles triangle, and so we know this length is also 5 centimeters. So that's the answer for the first part of this question. The length of DE is 5 centimeters. And then part 2 now wants us to measure angle ECD. So we need a protractor. And remember, the protractor must be placed perfectly so we can measure the angle. And if we look carefully, the axis of the protractor is placed at the vertex of the angle that we're trying to measure. That's right here. The base of the protractor is on the line that we're measuring from, and it passes through 0, and then we measure our angle from 0 upward to the line that we're measuring the angle to. And based on this, 0 upward to this line passes through now. This is 30, this is 40. This line here is 35, and so our angle is about 36.5. It is somewhere between 36 and 37. And so our angle on estimate is about 36.5. And therefore we can show that angle ECD is 36.5. Remember, the protractor has to be placed perfectly such that the axis of the protractor, or the eye of the protractor right here, is at the vertex of the angle we're trying to measure, and the base of the protractor must be on the line that we're measuring the angle from, passing through 0, and then we measure the angle from 0 upwards to the other line that we're measuring the angle up to. And so the answer here is 36.5 degrees. 37 also would be accepted, and maybe even 36 degrees would be accepted. Okay, but our answer here is 36.5. And so we can move our protractor and place our angle there on the diagram. This angle we have measured as 36.5 degrees. Now other dimensions that we might need to measure is the length of the base. because we will need this information to answer the subsequent parts of this question. And if we look at the ruler here, the length of the line CD is 8 centimeters, and you can see that G actually is the midpoint of CD. It is 4 centimeters from here and 4 centimeters from here. So CG is 4 centimeters and GD is 4 centimeters, such that the length of CD is 8 centimeters. So we can move that ruler and put that information there. That's it. Our CD is 8 centimeters, and we might also want to measure the height of that triangle. We could also deduce that we have a 3, 4, 5 triangle here, because this hypotenuse is 5, this side is 4, and so we expect that this height would be 3. That's a 3, 4, 5 right on a triangle. But the ruler, we place our ruler here from 0 down, and we see that the height here actually is 3 centimeters. And so we can move the ruler out the way and show that information. We can also measure and show that the angle here is 90 degrees. So we can bring the protractor back here and position it properly, and we see that the angle here is 90 degrees. The base from 0 is up to 90 degrees to this line, and so this angle is 90 degrees, and therefore we can show that on the diagram. So let's proceed and write that information there. The angle here is 90 degrees, and so we can move now to the other part of the question. Part 3 wants us to calculate or measure and state the perimeter of the triangle. Now the perimeter would be this length plus this length plus this length, the distance around the boundary of the isosceles triangle. That's the perimeter of triangle CDE. And so it would be CD plus DE plus EC. That would be the perimeter. And that calculation gives us 8 plus 5 plus 5. 8 across here plus 5 plus 5. And that works out to 18 centimeters. So the perimeter of the triangle CDE is 18 centimeters. Part 4 now wants us to calculate the area of the triangle. Now, since we have the perpendicular height is 3, and we also know that the base is 8 centimeters, we can use that basic formula for the area of a triangle: half base times height. And this is it. So the area of this triangle will be half the base, which is CD, multiplied by the height, which is GE. And so we can calculate the area of that triangle quite quickly. Half 8 multiplied by 3, and that result is 12 centimeters squared. And that's the answer for part 4 of question 4A. Let's move down now to question 4B. Now question 4B tells us of a line segment with endpoints A, negative 1, 4, and B, 3, 2. So we have a line segment AB, and these are the coordinates of the endpoints of that line segment. And the first part wants us to calculate the gradient of the line. The gradient of the line is the rise over run, or the change in y divided by the change in x, or the difference in y divided by the difference in x. And so this is it. The gradient of AB represented by this MAB is the difference in y divided by the difference in x. And we can take the difference in y by doing the B component minus the A component. But if we do the B component minus the A component when we are taking the difference in y, then we also have to do the B component minus the A component when we are taking the difference in x. So let's leave it like this, and we will do YB minus YA. YB means the y value at B, YA is the y value at A. XB is the x value at B, XA is the x value at A. And so we are doing the difference in y divided by the difference in x, and we are going B point minus A point, B point minus A point. And so the values become 2 minus 4 divided by 3 minus minus 1. YB is 2, YA is 4, so that's 2 minus 4. And then XB is 3, that's here, minus, that's this minus here, xa is -1. So it becomes 3 minus -1. And 3 minus -1 is the same as 3 plus 1. And then 2 minus 4 is -2. So this reduces to -2 divided by 4. -2 divided by 4 is the same as -1 divided by 2, because 2 divided here is 1 and 2 divided here is 2. And so our gradient of AB is -1/2, -1 divided by 2. Next, we are asked to calculate the midpoint of AB. So the midpoint of AB is calculated using a simple formula: the average of the x values between the 2 points and the average of the y values between the 2 points. So this is the x coordinate at the midpoint, the average of the x values, and this is the y coordinate at the midpoint, the average of the y values. And so we just simply need to substitute the values in this formula right here. And this is it. So the sum of the x values, that's -1 plus 3, -1 plus 3 divided by 2. And then the average of the y values is 4 plus 2. That's it. 4 plus 2 divided by 2. So that's the average of the x values and the average of the y values. And so the midpoint is the point 1,3. And we have called the midpoint capital M. So that's the coordinate of the midpoint. The point is 1,3. Let's move down now to part 3. So what we have so far is the point A, the point B, the gradient of the line AB, and the midpoint of the line AB. That's the information we have so far. Part 3 wants us to find the equation of the perpendicular bisector of AB. Now let's explain what the perpendicular bisector of AB is. And let's show it on the diagram. We're going to call the perpendicular bisector P, and the perpendicular bisector of AB, which we're calling P, passes through the midpoint of AB, which is this point M12, and also is perpendicular to AB. It is perpendicular to AB. That's what we have here. The line we're looking for is perpendicular to AB, and it bisects AB, meaning it passes through the midpoint of AB. So that's a perpendicular bisector. It is perpendicular to AB and also bisects AB. And by bisecting AB, we mean that it passes through the midpoint of AB. So we want the line that is perpendicular to AB and also that passes through the midpoint of AB. And as I said, we can show that on a diagram. So let's put down the point A and B on this diagram. That's it. That's the line segment AB. That's point A, -1, 4. That's point A. The point B is 3, 2. That's it. 3, 2. So that's a point B. So that's our line segment AB. And we calculated the point M to be 1,3. 1,3. That's the midpoint of AB. And then the perpendicular bisector now will be perpendicular to AB, passing down here, and will pass through M. So we can show that that line is our perpendicular bisector. That's P, our perpendicular bisector of the line AB. So we are trying to find the equation of this red line, right? So to find the equation of this line, we need the gradient of this line. We already have a point. We know it passes through the midpoint, which is 1,3. And so to calculate the equation of this line, we only now need to find the gradient. Once we have the gradient and we have this point, then we can find the equation of this line. But because we know that this line is perpendicular to AB, we can use the relationship between perpendicular lines to calculate the gradient of this line P, the line we're trying to find, and this is it. Perpendicular lines have negative reciprocal gradient, meaning that when two lines are perpendicular, the gradient of one is the negative reciprocal of the gradient of the next. And this is it. The gradient of the perpendicular line is equal to -1 divided by the gradient of AB. That's because they are perpendicular. The gradient of one is equal to the negative reciprocal, the -1 divided by the gradient of the other. That's a negative reciprocal of AB. The negative reciprocal of the gradient of AB is equal to the gradient of P, the perpendicular line. And so we do that calculation by what we call flipping and changing the sign. To carry out this calculation, we can flip the gradient of AB, and so this negative 1 over 2 would become 2 over negative 1, and then we change the sign to 2 divided by 1. So the negative reciprocal of negative 1 over 2 is actually just 2. Flip it, it becomes 2 over negative 1, and then change the sign. 2 over negative 1 is negative 2, and then change the sign to 2. But to show that calculation, this would be it. Negative 1 divided by the gradient of AB, which is negative 1 over 2. And when we flip and change the sign of this gradient, if we carry out this calculation, we see that the result is 2. Flipping and changing the sign is a simple way of calculating negative reciprocal gradient. And so the gradient of the perpendicular line here, the perpendicular bisector that we are trying to find, is equal to 2. So let's move down and complete this calculation. And this is it. We are trying to find this line. And this line passes through this point, 1, 3, and has a gradient of 2. Now that we have a point on the line that we want, and also the gradient, we can use the point gradient formula to calculate the equation of this line, the perpendicular bisector of AB. And this is it. The equation of the perpendicular bisector would be y minus y coordinate at the point equal the gradient of the line into x minus the x coordinate of the point that the line passes through. And this is the point gradient formula. Ym and xm here are the coordinates of the point on the line that we know, that's the point M, and this is the gradient of the line. And all we are doing now is substituting for these values. Ym is the y value from here, xm is the x value from here, and mp here is the gradient of the line too. So we can substitute those values and we will extract the equation of the line. And this is it. Y minus 3. 3 is the y value at the point that we know, the m. The gradient is 2. So we place the 2 here. And 1 is the x value of the point that we know that this line passes through m. And so xm, that's the value of 1 here. And so the equation of a line is this. We can now just simplify this equation. And so this side expands to 2x. 2 times minus 1 is minus 2. So this side expands to 2x minus 2. Y minus 3 remains on this side. And then we can add 3 to this side. And so when we do that, we take this negative 3 onto this side and we end up with 3 minus 2 is 1. And so the equation of this perpendicular bisector is y equals 2x plus 1. And we can see this plus 1 is a y-axis intercept of this line. See? Passes through 1 here. And the gradient is 2. Rise over run is 2. So from this point to this point, rise is 2. 1, 2, and the run is 1. And so that confirms that this is the correct equation of this line. The y-axis intercept is 1. And the gradient is 2. Rise over run is 2. From this point to this point, we rise 2, 1, 2, run 1, run 1 to get to this point. And so this is the equation of the perpendicular bisector of AB. And that's the answer for this part of the question, question 4b, part 3. And that's the end of question 4. And we'll do question 5 in the next video. See you then.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.